All right, Mr. Little here, bringing y'all video 2 on module 6. For our first video, or previous video, we focused on correlational studies, remembering that keyword. Where did I put it on here? Correlation does not always mean causation. What we can do with correlational studies, which is make predictions, and what we can't do, which is draw causal relationships. But the focus of this video is we're going to shift gears to talking about experimental design, how to design an experiment, what conclusions we can draw from an experiment, and where one of those might be useful. So first we want to just get a clear definition of what an experiment is. And for those of you who are coming from Ms. Dahmers's unit, you've already came across a number of experiments. You probably have a good idea of what an experiment looks like in your head. But two of my personal favorites are the Stanford Prison experiment. I'm very jealous of Ms. Dahmers for getting to teach the social unit as well as Milgram's obedience study. But just to put an experiment into a more kind of concrete definition, an experiment is a research method in which an investigator, keyword, manipulates one or more factors in a controlled setting to observe the effect of some behavior or mental processes. And it's what you would conduct if you want to take a theory and prove that one thing actually causes another thing. So this is something that is a limitation of just looking at correlational data, but something that you can come closer to with an experiment. So I want to actually take a step back and start this with a hypothetical theory that we might have. Let's say I'm teaching my class and I notice that students who come in with a big cup of Starbucks or a Bang energy drink or something like that are, it's my terrible way of trying to relate to you all, are tend to do better in my class, tend to seem like they're more focused, and I feel like they're getting better grades. So I come up with a theory that caffeine improves academic performance. Now, remember in our process or our scientific method, we first want to come up with a theory, then a hypothesis. But let's go ahead and skip ahead to how we might want to study this and just go through kind of a review of all of the different kind of studies we went over. So the first option would be, do we want to look at this through a case study, look at this claim that caffeine improves academic performance? You probably could do this. You could pick one student, explore deeply how much caffeine they drink and see how that impacts their academics. But this would definitely not be the best way to do this. Maybe you'd gain some insight about that individual student's experience, but we know that you would just be looking at one case and you couldn't generalize this to other students. They might have a very specific case. So we'll say case studies are out the door. Now, how about naturalistic observation? This is something that might kind of work. You could observe, and this is something that I've kind of already been doing, observing students who come in with coffee, noticing which ones do better on exams or how they behave. Issue with this, though, is it's very, very subjective, what I'm looking at. So it may even be the case that students are coming in with decaf. It may be the case that certain students drank coffee before and aren't coming into my class, but just aren't coming into my classroom with coffee. So we're going to throw naturalistic observation out the door. We could also do a survey. This would be something where we ask students about their attitudes towards coffee, we ask students how much coffee they drink and how much they feel like it helps them with their academic performance. That might also give us some insight, but remember, this is just the account of students. We're not really looking at this very systematically, and it would also be very subjective. So we're going to throw a survey out the door. Finally, we have correlational studies, and this could be interesting in testing this theory, right? We could do a little survey on students to see how much coffee they drink and then compare that data to how they do on their exams. But of course, the only issue there is that would not prove causality. We have that third variable problem. It might be something like more motivated students also are more likely to drink coffee. And there might just be the case that for some reason, students who drink coffee just happen to also be better academic performers. So correlational studies could probably give us a lot more insight than these other three, but it still would not be our ideal theory. I think you know where this is going. The thing to use here is experimental design, and that's because this will show actual causality. And what we mean by that is if you look at the wording of this theory, remember we're not saying caffeine and academic performance are related to one another. We're saying that caffeine is the single thing, the independent variable that improves academic performance. So to support this theory, we want to test whether caffeine actually causes an increase in academic performance rather than it's just related to it. So our next step then would be to form a hypothesis or a testable prediction about an event that would support this claim. So let's just say our hypothesis then is students who consume at least 60 milligrams of caffeine per day will receive better grades on their research methods exam, which is coming up quicker than you would like it to be, than those who consume less than 60 milligrams of caffeine daily. And note here, just another review, remember a good hypothesis tends to have operational definitions embedded in it. So you can see here my operational definition for caffeine is at least 60 milligrams of caffeine. And then my operational definition for academic performance is better grades on their research methods exam. Remember, operational definitions are how we define our variables or how we measure them. All right, so now we want to talk through what we would actually do in an experiment to test our previous hypothesis of whether students who receive caffeine will perform better academically than those who do not. So the first term we want to unpack here is random assignment. What do we mean by this? Random assignment is how when we have a pool of participants who are going to participate in an experiment, we assign them to one of two groups. So the first of these groups would be the experimental group. So this would be the group that would actually receive what we would call the treatment or the independent variable, or in the case of this study, the caffeine. So half of the students would randomly be entering the experimental group, and then the other half would go into what we would call the control group. And the control group in an experiment is the group simply that does not get the treatment. This group is really, really important because we don't just want to measure the effects of this group. We want to have something to compare it to. So we want to know that a group that receives caffeine doesn't just do well academically, but does better, or doesn't do well on their research methods exams, but does better than a group that does not receive caffeine. That's how we're going to determine whether or not the caffeine actually worked. Next term we have here, and I actually want to point out that realize that the control group is not just receiving nothing, they're receiving decaf. And the reason for that is what we call the placebo effect. And some of you may have heard of this before, particularly if you were following the COVID vaccine trials. So the placebo effect is the idea that just by thinking you're getting something that's going to have an effect, those expectations alone might affect your behavior, and you might act in a certain way because of that. So, for example, in this case, if we were to give this control group nothing, no coffee whatsoever, and this group coffee, this group might be a little bit more alert. They might be a little bit more focused, not necessarily because of the caffeine, but just because they think they're receiving caffeine. So the way to combat this is to give both of these groups some kind of coffee, and half of them would get caffeinated coffee, half of them would get decaf, but you wouldn't tell them whether they got caffeine or whether they got decaf. And that's what we call a double-blind procedure. So both the students, and I want to add here, the teacher also doesn't know what condition people are in, because you don't want the teacher to treat one group differently than the other in hopes that maybe they hope that the caffeinated group will do better because it proves their hypothesis or something like that. So that's double-blind procedure. Neither of these groups can know what condition they're in or what type of coffee they're receiving. So now that both of these groups are receiving some kind of coffee, they don't know which type it is. The only thing that we can really attribute better academic performance from this group to is not the placebo effect, but the actual effects of the caffeine itself. And a common theme that we're going to talk about when we talk about experiments is that the goal of an experiment is to eliminate as many possible alternative explanations as possible. So that's what we're aiming for here. And on that note, some other considerations that need to be made. This is another word from your book, which is confounding variables. So a confounding variable is a factor other than something being studied that might influence the study's results. So a prime example of this might be if I were to test a group of people on memory, and half of the all of the participants in one condition were tested in the morning, all of the participants in another condition were tested in the evening, then I would have that third variable or that confounding variable of time of day that might also impact the study. So you want to be really careful when you run an experiment to control for as many of these as possible. So in the case of this study, just some examples of this are you would want to give an equal amount of coffee to all of the students. You wouldn't want some of them drinking a lot more coffee than others, as that might affect the experiment. So you want to control for that. You would want to control where students sit. Make sure it's not just all the caffeine drinkers sitting at the front of the class. This might also impact the results. And also, I would want to run this study for just one single class, and like my second hour. And the reason for that would be that all of the students would be in the same class period. It would be during the same time of day, so we're controlling for time of day. And also, they would all get the exact same lectures, the exact same homework, etc. So that just paints a really, really quick picture of what experiments look like. We'll unpack and dive deeper into some of these concepts in class, but hopefully that gives you a good way to connect the terms you learned about in your book to a real-life example. And I will wrap this up here. Thank you all.